Today, with practical examples, we are gonna see how we can develop new improved varieties starting from natural populations. Inside the breeding box, there are three main tools we can use. These consist of phenotyping techniques, the crossing and selection schemes or breeding schemes, and genotyping techniques. In order to enter or exit from the breeding box, we need to pass through the access point. In our example, number from 1 to 4. At each access point, it is necessary to perform specific activities using the tools available inside the breeding box. For the moment, we will focus only on phenotyping techniques and breeding schemes. By the end of the chapter, we will see how genotyping techniques can boost our varietal improvement project, but still rely on phenotyping and breeding schemes application. In our case, we want to enter with a natural population from access point number 1. The necessary task is to characterize the original population for as many characteristics as possible. For each characteristic, it is necessary to evaluate three main aspects, extremely useful for the further process of data collection and analysis. The timing for the evaluation must be defined before the beginning of cultivation. It is possible, for example, to identify a certain growing degree day value or a specific stage of the plant development. We must also take into account the type of technique we are going to use, specifically if it requires the harvest of the total plant or if it can be assessed directly in plant. It's also important to determine if one measurement has effect on other characteristics that I'm going to evaluate on the same plant maybe later in the cultivation cycle. The last aspect for our cultivation planning is to determine the type of value we have to measure. For example, if it is a numerical value or if it is a categorical value. Planning our timing technique value is necessary to determine the resources we need to invest during the selection along the cultivation cycle. After data collection and analysis, we can identify three main actions we need to operate in order to compile the ideotype, so the ideal type of our improved population. First, we need to individuate deleterious characteristics we need to completely remove from the original population. Second, we can select some characteristics within a specific range of numerical value that are not homogeneous in the original population. Or alternatively, if present, we can select superior plants that eventually resemble and even exceed the population ideotype. After the characterization of our natural population, we can compile the breeding note also using the type of selection we are going to apply in order to exit from access point number 2 with the improved population. As you can see, each characteristic is described using the timing of evaluation and selection, the type of measurement and value, and the resulting action to be operated during the selection. Now it's possible to use the breeding scheme tool and start the first cultivation cycle. To avoid the consultation of breeding note every day, we can summarize the selection point we want to apply during the selection cycle. The symbols that I use are in a certain way taken from the classical pedigree legend. Square, tilted square, and circle represents the type of selection that I'm going to apply exclusively on males plant, on females plant, or on both sex. Moreover, we can use the cross to individuate deleterious characteristics we need to remove, or alternatively the plus and minus for characteristics we need to select according to a certain range defined in the breeding note. Sometimes, during selection and crossing, some superior plants can be detected inside our population. The superior plants can resemble or even exceed our ideotype. So, in this example, we propagated the male B, the female W, and the plant I with unknown sex, if we propagated before the beginning of flowering. So we have to give a letter to name a specific plant inside our population. In the case the propagated plant resembles the ideotype, we can eventually use this superior plant also inside the population improvement schemes. On contrary, if the propagated plant doesn't resemble the population ideotype, but for example is superior for other characteristics, it's possible to use this plant later to develop inbreed lines, but definitely it's better to remove it from the population improvement scheme. Finally, we can start with our cultivation cycle. During vegetative phase, we need to operate a single selection on all the plants and removing the one with a columnar habitus. At the beginning of flowering, before the beginning of pollination, we need to select both males and females for the growing degree days at the beginning of flowering, and males exclusively for their plant age. Another selection we need to apply before the pollination, and so before the beginning of seed setting, is the removal of all the plants exhibiting intersexual or hermaphrodite characteristics. Before the harvest, we are going to select exclusively females according to the previously defined range in growing degree days at the end of flowering. At harvest time, we simply mix all the seeds from selected females and start again our breeding cycle using the first generation of improved population seeds. After a certain number of cycles, we can be able to obtain an improved population for almost all the characteristics we are selecting for, except for the growing degree days at the end of flowering, that we cannot further improve using this breeding scheme for population improvement. So at this point we can consider obtained our improved population. Now, to exit from access point number 2, we need to include in the breeding note of the improved population all the data obtained from phenotyping and breeding schemes as well. The breeding scheme used in this first example, using a natural population as starting material, is called recurrent phenotypic selection, meaning it is applied for a repeated cycle and is based on specific phenotypic characteristics. This selection scheme is usually adopted when starting from big population, with generally good characteristics and low presence of deleterious plants. It is very effective when we apply selection for characteristics on both males and females plants before the beginning of pollination. When starting from big populations, there is a second type of selection that is often used in cannabis breeding, the mass selection. The main difference is that in the previous case we selected at different points along all the cultivation cycle, while the mass selection operates a single selection at harvest time, but doesn't require any selection on male plants before pollination. So technically, in the moment we found a natural population in its environment, if we take seeds exclusively from few best females, instead of picking few seeds from all the females, we are applying a mass selection. I would not recommend to use recurrent mass selection in cannabis breeding, apart from few specific cases, because its improvement at each generation is limited compared to other breeding schemes. Before to start with inbreeding lines, I think it's important to make few considerations on what we have done in this first recurrent selection. First, we collected data of natural population for its initial characterization in the new environment, and set 5 characteristics to be improved during the recurrent selection. In our case, we want to keep a population with a certain degree of variability, while improving few general characteristics applying a low level of selection. For example, starting with a population of 1000 plants, at the end of first cycle, we mix the seed from 170 selected females, pollinated by 290 males. Cycle by cycle, the new generations should be enhanced for the characteristics we are selecting for, and, according to the ideotype, we should need to remove less plants until the moment we don't need to operate no more selection, ideally keeping almost all the males and females plants inside the new improved population. Unfortunately, natural populations are often composed by high number of deleterious plants, and maybe our starting population is little, let's say less than 1000 seeds. The previous scheme can result in a final low number of plants selected. In this example, starting with 500 seeds, at the end of cultivation cycle we selected only 6 females that have been pollinated only by 10 males. If this is our case, after the characterization of the natural population in the new cultivation environment and the ideotype definition, I would recommend to propagate the few plants selected during the vegetative stage, and directly create inbreeding lines, instead of start further cycles of recurrent selection. We can also consider to discard a population or to define a new hydrotype for a different breeding project. In the next part of the video, we will see how we can use superior plants maintained in the propagation area to create inbreed lines and finally start to introduce the genotyping techniques for the production of superior hybrid varieties.